Matrix multiplication, the general case, which is really the last case we talked about, just done multiple times. Alright, so this would be if I have matrices that are bigger than just a single row and a single column. Alright, so I've got my matrix A, that is an M by N, so M and N would be its size. I have M rows and N columns. Matrix B is a P by Q, so it's got P rows and Q columns. First of all, we define it, we're going to do a bunch of rows times columns. And my first matrix represents my rows, just like in the simple case. And my second matrix represents my columns. And so in order to do the math, in order to be able to multiply A times B, I have to have the same number of values in my row as I do in my column. So if you remember from before, I had one row and three numbers. Well, those three numbers were the columns, right? And then I had three rows by one column, right? And so those threes had to match up, right? The number of entries had to be the same. And so that's what we have to check. The N and the P have to match up because that's telling me I've got enough numbers in each row to multiply by the numbers in each column. All right, so I have to have those have to match. All right, if they do, then we can do the math. The math is defined. The operation is defined. I can find the AB, and actually the outside numbers actually tell me how big my resulting matrix will be because this is the actual rows and columns I'm going to multiply. I'm going to take my M rows times my Q columns, and so that's how big my resulting matrix will be. You do that by basically doing the math we did in the last video for every row and every column. Every row in A by every column in B. All right, so when we take the product of AB, you take every row in A, multiply it by every column in B, using the exact same method we did in the first definition. Alright, so if I've got my matrix A here, so my matrix A would suppose it's got two rows and two columns. So it's got A, B, C, D. Alright, and so my matrix B, suppose my matrix B was a 2 by 1. So there's my A, there's my B. So this would be a 2 by 2, this would be a 2 by 1. Right? And so what we check, this is my M by N, this is my P by Q. And so what you check is, do those middle numbers match? So this would be my N. Does it match my P? And it does. In this case, they're both 2, and so that checks. This 2 matches with this 2. That means I've got two numbers in my row, and I've got two numbers in my column. That's what those 2 represents, right? I've got two numbers in my row. Right, that would be my row 1, and this would be my row 2. Every row has 2 numbers in it. This would be my column, and there's only one column. So that's why we check those. Those are checking how many numbers I have in each of my rows. Do I have the same number of numbers in each of my columns? And I do. And so that's why we check the NP. I can only do the math if I've got the right number of numbers in my rows and my columns. And then the outside values, the M and the Q, are actually the multiplication part. I've got 2 rows, and I'm going to multiply it by 1 column. Right? That's what I've got. That's what the Q represents, is the 1 column. And so when I multiply this out, I'm going to take row 1 times column 1 and row 2 times column 2, and I am going to get a 2 by 1 out. That's what the second statement is saying. So I do the same math I did in the previous case. If I do this generic case, what I did in the previous one, so in order to get that 2 by 1, you would take A times F, so you just get AF, add to it B times G, so you get plus B, and there's nothing, you just leave it AF plus BG, so those aren't actual numbers. And there's my first row by my first column. And then I do the same thing for the second row. Right? So I take the second row times the same column, and so I get C times F plus D times G, and there is my 2 by 1 matrix doing my multiplication. All right, allows me to do when I again multiply down this row. So again, left to right down the row, top to bottom in my column, just like the last example. Excuse me. All right, matrix math is a little more limited, right? I have to have these specific things in order to make it work. All right, so the first thing I'm just going to talk about is when can I do the math and when can I not do the math. And it's always the first matrix is my rows, the second matrix is my columns. Always. That's how the matrix math is defined. You can't do it any other way. So I've got these 4 matrices here, and I want to know if I can do the math. So I'm actually going to write it up here so I can look at them at the same time. Alright, so my first one is, can I take A, multiply it by B? And if I do, what will be the resulting matrix? If I actually multiply them out, how big would be my A times B? Right, and then I flipped it around, did B times A, and how big would be B times A? Alright, well I checked my dimensions. A is a 2 rows, 3 columns. A is a 2 by 3. B is a 3 rows, 2 columns. And so I look to see if the middle numbers match, and they do. And what that tells me, let me check to see if they're equal, is that I have 3 numbers in my row, and I have 3 numbers in my column, right? That's what it's telling me. That 3 means I've got 3 numbers in my row, and the 3 in the B is telling me I've got 3 numbers in my column, which means I can do the math, right? If I've got enough numbers in each row to multiply by enough numbers in each column, I can do the math. When I do the math, I'm going to take 2 rows times 2 columns. And so the resulting matrix will be a 2 by 2 when I do the math. Right, if I did the math. Alright, well what happens when I flip it around? Alright, so if I multiply in the other direction, so B first, A second. So B is now my rows. A is now my columns, right? Because when I order matters with matrices, because the first matrix represents my rows in my multiplication. The second matrix represents the columns in my multiplication. Alright, so B is a 3 by 2. A is a 2 by 3. And so the middle numbers do match, right? Those are 2s. And again, what that's telling me is I have 2 numbers in each of my row that I can multiply 2 numbers in each of my column by. So that checks. And when I do actually do the math, these are the rows and these are the columns I'm actually going to multiply. So I'm taking the 3, right? There are 3 rows in B. So I'm going to take the 3 rows in B and multiply by the 3 columns in A. When I do that, my resulting matrix is going to be a 3 by 3. And so if I actually so if you'll notice, it does matter what order I multiply in. When I take A first, then B, I get a 2 by 2 matrix. 2 rows, 2 columns. When I flip the multiplication and I do B and then A, I get a bigger matrix. I get a 3 by 3 matrix. Alright, so order matters. Alright, the next ones I was going to look at was B and D and C and D. And we'll do B and D, so I'm going to erase it because I'm going to do it here because I think it's easier to see my matrices and talk about them at the same time. Alright, so taking matrix B times matrix D, and then taking matrix C times matrix D. Alright, so matrix B was, remember, a 3 by 2, right? 3 rows, 2 columns. D is also a 3 by 2. Alright, and so what you'll notice here is those middle numbers don't match. Even though they're the same size, I could add them, but I cannot multiply them. Because if I were trying to multiply them, my row in matrix B only has 2 numbers. My column in matrix D would have 3 numbers. And so I'd run out of numbers. There's nothing to multiply that 2 by. Once I multiply the 2 by the 5, the 4 by the 9, I ran out of numbers. And so I cannot do this. This does not work. And so we say the operation is undefined, or I just like to simplify it and say undefined. Can't do the math. Undefinable. I run out of numbers. Alright, so even though they're the same size, I cannot multiply them, but I could add them if I wanted to. I can add, can't multiply. Multiplying is tougher. Alright, now C and D. Alright, so C is a 2 by 2. D is a 3 by 2. So again, those middle numbers do not match. So this would be undefined. And if you look at it, C, same problem I had before. I've got 2 numbers in my row, 3 numbers in my column. I can't do the math. What happens when I flip C and D? So I'm actually going to leave that one up here, and I'm just going to erase the one above it. Alright, so I have C times D there. And so the last one I asked you to do was, well, what if I flip D and C? Alright, so I'm going to take D first, then C. Alright, so D was a 3 by 2. C was a 2 by 2. This time, my numbers match. If I go in that order, D first, which represents my rows, C second, which represents my columns, now I can do the math. The other way I couldn't, this way I can. You can check it. So D represents my rows. Well, I've got 2 numbers in each of my rows for D. And when I go to my C, I've got 2 numbers in my columns, and so I can do the math. And then what math do I do? Well, I take my 3 rows from D and multiply them by my 2 columns from C. And so if I actually multiplied those out, I would get a 3 by 2 matrix. So order for matrices matters. I cannot flip the order. I change it if I do, right? And this is a great example of where that happens. One direction works, right? I could take D and multiply it by C, and that gives me out a matrix. But when I flip it around, I can't. Right? If I take C first, then D, it's undefined because the rows don't match up. So the numbers in my row and the number in my columns don't match up. And so with matrices, order of operations, the order you multiply in matters, which is different than numbers, right? If I take 3 and I multiply by 2, right? If I take 3 times 2, it's the same as 2 times 3, right? Those are both 6, right? Number I can flip around. Matrices I can't. With the way the matrix math is defined, I cannot flip the order the matrices are multiplied. I get different numbers if I do. Alright, so there's the general case. And so in the next videos, we'll actually practice multiplying.